All right, in this presentation, I'm going to go over benchmarking and energy use index. So we'll go over what energy use index is, what benchmarking is, um, how building size, location, and use impact um, both of these, and then how does it help improve energy efficiency? So I want you to think of yourself, you're an energy manager, you're a building manager, and you operate these five buildings, and you want to know which one's operating more efficiently. And all you have is a year's worth of utility bills, okay? And so you have building A through E. Here's the square footages, so we have various square footages. Here's the total energy used for the building based on your utility analysis. And then here's the building type. So feel free to press pause and think about like which one of these do you think is most efficient? That's pretty hard to tell from this information, and we'll go over some additional information that can maybe help you out. So you want to think about when thinking about the energy efficiency of different buildings, you have to think of a couple of different things. So if you think about um, what the building's used for and how that would impact energy use, I want to, feel free to press pause and think about what could be the possible difference between like a hospital, store, and a school. And if you think about it, something like a hospital. This is a local hospital here in Delaware, really big hospital complex. And then here's a Best Buy retail store that's near, right down the street from them. So I think it's pretty obvious that you would expect the hospital should use a lot more energy than the Best Buy. There's a lot of equipment. It's a 24/7. There's all kinds of medical equipment. I mean, there's climate control. There's sanitizing needs for for various pieces of equipment and so forth. I mean, there's just a lot of energy. It's constantly in motion. It's constantly doing things. Whereas a store, it's going to close overnight. It might, it's not used 24/7. Now, Best Buy is kind of a weird example because they do have a lot of electronics, but most stores, like a regular clothing store or something, they're not going to use much energy at all. So you have to think about the energy use and consider, like a school and how that's different than, say, like a church or something like that. Um, and what about different sizes? So if you think about it, if you want to, again, the goal here is to find out if something's more efficient than something else. And so you think size would be really important. So this is a local community college. Um, 200,000 square feet, really big. And this is a little, it's like a middle school, and it's maybe, 1,000, 1,500 square feet. But the point is that you would expect, all else being equal, that this would use a lot more energy than this. Pretty straightforward. So size is really important stuff. And finally, if you think about different areas of the country or different climate zones, that's also important too. Because so to take a kind of extreme example, but it's important. If I have this, take this exact building, right? So the same Best Buy building. Let me plop one down here in northern Minnesota and one, let's say, in like central California along the coastline. Now, it's really cold in northern Minnesota, super, super cold winters. Summers aren't too bad, but California's mild year round. So you would expect this same store in a place like Minnesota would use more energy than a place like Central California. And so the location matters. And so all of these, again, if you just have the utility information, you need to know how big the building is, you need to know what the building's used for, and you need to know where the building's located, at least approximately. So all of that helps us determine what's called benchmarking. And so first, the core metric for benchmarking is called energy use intensity. So you want to jot down EUI, or energy use intensity, energy use index, energy utilization index. It's all EUI, no matter how you slice it. So EUI is really simple to derive. All you do is you take the total energy used per year, and you convert that to thousands of BTUs and divide that by the area in square footage. All right. And so you end up with kBTU per square foot. And that's it. That gives you your EUI. Now you can take ECI, or energy cost index. This is less common, but you take the total annual utility cost and divide that by the square footage, and that can give you some indication of how much they're paying for energy. And so the EUI is this really great metric. It's used all over the place. Um, and it's kind of a rough way, but it's a good like indicator of the general efficiency of a building. So with regards to different uses, remember it's important. And here, these are national numbers for different types of building in a certain climate zone. And you can see a hospital, inpatient healthcare, is going to use about 283 kBTU per square foot, whereas a religious worship, kind of on the other extreme. You think about it, most or a lot of churches and a lot of other religious institutions, temples, and uh, so forth, mosques, etc. They're used less frequently than something like a hospital uh, or even a retail. And so you have less average kBTU per square foot. And so when you're comparing the efficiency of a building and you're using EUI, you need to know what it's being used for. So you can see there's a very big difference um, across different building types. All right, so let's take a look. Now we have let's take a look at these numbers and say we'll have a little more information to help us make a decision on which one is efficient. So these are the same for five buildings as before. And so if we calculate the UI from the MMBtu in the square footage, it's a really easy calculation to do. You can see the EUIs here. So now we're kind of getting somewhere, right? So we can see 100, 100 for these two colleges. We have 66 for this college, 176 for this hospital, and 62 for this church. Now, the last piece of information that will help us determine sort of the general efficiency of these buildings is finding the typical EUI for that type of building in that climate zone. And so now we have enough to determine how well the building's doing. All right. So we look at, these two colleges both have 100 kBD per square foot. That's a little higher than average. Um, this college, however, is much lower than average. So that's relatively efficient. And then we have the hospital, which is actually, despite the high energy use per square foot, it's actually much lower than you would expect for a hospital. And then the church, despite having relatively low energy use, is a lot more than you'd expect for that, right? So the two that are really the most efficient out of all of these are the college and the hospital, even though they're not the lowest per square foot energy use. Okay, so you have to take all of these factors into consideration. And that's one way the EUI is used. You can get the EUI for the building that you're operating. Just you need a year's worth of utility bills and the square footage, and that's it. And you can compare it to how you're doing with other buildings in your sort of category. Now, taking this to the next level is something called benchmarking. And again, this is something that's done all over the place, including it's mandatory in commercial and multifamily residential buildings in the city of Philadelphia, everything over 50,000 square feet, which I'll go over in a second. But this is used all over the place. Okay, so benchmarking is comparing your EUI with buildings of similar uses in the area to determine how efficient it is, relatively speaking, anyway. And so there's a free software called Portfolio Manager, Environmental Protection Agency. Um, and so this is freely available to anyone, but a lot of building managers will use this to get their what's called an energy score. And this is really helpful because what you do is you just enter in all your information for utility bills and building size and where it is and all that sort of thing. And you enter it in, and then what it does is it gives you what's called an energy score. What this database does is it's over time people just keep adding more information to this about their building. And so really it just ends up being a really big database of buildings. And then once you enter in your information, they give you what's called an energy score. And the energy score is really intuitive. An energy score of 50 means you're more efficient than 50% and less efficient than 50% of buildings in your category. If you get a 75, that means you're more efficient than 75% of the buildings in your category. So it really just means your EUI is lower than 75% of the other buildings. And so if you get something like a 20 or 25, you're not doing really well. That means you're only more efficient than like 20 to 25%. And so this is really great because it gives you a good snapshot of how you're doing relative to other comparable buildings. But the other nice thing about this, as more and more people enter in their information, you get more comparisons. And what a lot of municipalities like Philadelphia will do is you have to do this every year, so you have to keep updating your score. But what's great is if let's say you have a building and you're like, you get your 75 and you feel pretty good about yourself, but then all these other buildings get more efficient. And then if you think about it, your score is going to drop if you don't upgrade your efficiency as well. So it's this sort of iterative process that sort of continues to motivate people to reduce their energy use and reduce their index. And so there's actually this is from the city of Philadelphia, their own benchmarking website. You can explore it. And all commercial and multifamily buildings over 50,000 square feet in Philly have to benchmark every single year. It's actually a law, and there's like penalties if you don't do it and so forth. But Philly's not the only one. You can see 39 cities require it annually, and so this is something that is used a lot, and it's a really sort of efficient. It's really not that difficult to do, and it can be an effective way to help buildings reduce their energy use. Okay, so now you should have a pretty good understanding of what an energy use index is and why size, location, and use are important, and also have a good sense of what benchmarking is and how it helps improve energy efficiency.